Hello, everyone. This is going to be a great mini tutorial on the use of Rhino and an introduction to Grasshopper by our former El Camino student and present grad student of USC, Eric Yu. So he's been using this now for, oh my goodness, 2 years already, huh? And
Yeah,
gotten
two
got
plus years.
to getting
Oh,
getting really acclimated to it. So we're going to
oh.
start this off as a nice little introduction to the program. So hope you all enjoy it. Take it away, Eric.
Cool. Thanks, Ruben. Thank you so much. Just a couple things. To start off with, Ruben's AutoCAD class is very helpful. So if you haven't taken that, I would suggest taking that class. That a lot of the same ideas and the same tools are in AutoCAD with Rhino. Uh, yeah, so I would suggest starting off with Ruben's AutoCAD class if you are able to have a chance, and then later on, yeah, figuring out Rhino. But yeah, let's get started. So, a couple of things. I had my Rhino just automatically open so I could share screen. But when you first start Rhino, make sure when you start a new project, make sure it's architectural, and then make sure it's the right units that you have. That makes a huge difference because you don't want to be in millimeters and stuff. So, unless you do, but I would suggest making sure that it's the right units, whether it's feet, inches, or feet and stuff. To double check, you could just type in units, and so that now will actually show you what units I'm in. I'm like, right now I'm in feet, which is what I want to be for our architecture. But and if you need to change your units, and you just click on the units drop down, then you could switch it to inches or whatever units you need. Okay. So the difference with Rhino is it's intrinsically a 3D software. The history of it was that it was made to design boats and design jewelry. But then architects realized how amazing it was, and realized it was also uh, uh, cheaper than CATIA, and but had the same principles of CATIA. And so a lot of architects are now using it. Uh, and what's really important, and why a lot of schools, not just USC, but a lot of schools are using Rhino, is because they use this thing called NURBS. NURBS are basically it's 100% accurate because it uses mathematical formulas and equations to come up with those forms. So I'm not knocking SketchUp, but unfortunately, SketchUp doesn't use NURBS, and so whatever you create is not 100% accurate sometimes, and so that's why a lot of the architecture schools use Rhino now, because mathematically they want to make sure that everything's accurate, especially if you're doing any parametric and grasshopper stuff. Okay, so let's get started. On the right is your layers. I'm sure if you were in Ruben's class, he's kind of gone over some really great tips about keeping your layers organized. Make sure you keep your layers organized. That would make your life so much easier. Yeah. And so let's just start off with some 2D drawing. Let's treat it as AutoCAD. Okay. So I'm just gonna do a two-dimensional drawing. So I just, changed my layer. Um, and then I'm gonna remove the default layer. So I'm gonna right click to remove layers. So this is my 2D drawing. And then you could also change your line types. So you could change it so it's continuous, dots hidden, and so forth, And yeah. So you have four windows, and so to do two-dimensional, I just double click the top. view, and that's my um 2D view. Okay. Um, Sometimes if you can use the grids, I prefer not you to use the grids a lot of the time, so I could just press F7 and the grid disappears. But if you want to leave the grid on, you just type F7 again. Um, let's start off with some basic shapes. Okay, so you could just start off with a zero circle, and just like AutoCAD, it's you could type click on a tool, or you could type the tool. So if you type in circle, it'll pull off the same thing. So if you notice on the top of my screen, it says center of circle. Where do I want to start of my center? So I usually like to start at 0, 0, 0. Okay, so I'm gonna type. And then I could do my radius. Actually, it's diameter. So I'm going to do 5 feet. Okay, so this is it doing? Oh, yeah, 10 feet. All right. Why is it lagging? Oh, there we go. All right, cool. Yeah, so that's my circle. Okay, I also could do a square, rectangle. I could do some lines here, yeah, and so forth. There's curves. There's different ways of doing curves. And so you could, if you right click on the bottom, it kind of goes over different ways of doing curves. And so yeah, so this is a curve. If you right click, I mean not right click, if you click on the tiny little arrow here, it gives you different options as well for each of these things. So yeah. Yeah, and so you could just explore. I would, I would suggest exploring a lot. Um, so let's say a couple things. Let's say you want to do a floor plan. You could do a floor plan on as if you're doing AutoCAD. Okay. Let's say this is my my uh, building, and I could do an offset and 0.5 feet. That sounds great. And then I'm going to offset inside. Um, that's so I have my walls here. I could maybe have some openings for, you know what, let me create some more. And what's really important is on the bottom here is your snaps. And so this is how when I draw something, it snaps. So you can see how it snaps. So like right now it's snapping in the middle and so forth. So yeah. So let's say I'm going to create some more walls. So I'm just going to maybe go here, perpendicular intersect, and then maybe I'll do another wall here, you know, and then I have to show some thickness. So maybe I'll do an offset, and then here on here, and then offset on here. Yeah. And then let's say you need a opening for your doors. Okay, so maybe I'll start. I'm going through this kind of fast, but yeah. I maybe I could do a little door here. So start here and then do a little line showing this door, and then uh offset maybe 4 feet. And then that's what if I want to do an opening, then I select just like AutoCAD, I could select these two lines and trim. And here's my opening. Um, and then what's really nice is if you I know in Ruben's class he has a lot you guys did a lot of symbols like doors and windows. You could actually load those in. I've used those symbols as well. So if you go to file and import, you could import an AutoCAD file, and then you could bring in those symbols as well. Okay. Let me do yeah. So yeah, that's 2D drawings. And so you could start thinking about extrusions. So to start doing extrusions, let me clean this up. So maybe I tr uh, trim things up. So I could trim, so I could, extrude these walls. Done a lot of Rhino, so I'm a little, kind of faster, but take your time. Yeah, just use it a lot, and you'll pick up the speed. All right. So let's say I want to extrude things. Okay. So I double click top, and then go to my perspective view. Okay. So here's my some 2D drawings that I could extrude. Just like how you people extrude in SketchUp. Okay, so but this time I could just type in extrude curve. Okay. And then so I'm gonna click this and then click enter. And then uh here's a really important okay, so, surface. Okay, cool. Direction both sides, solid. Okay, here's a really important thing. When you extrude, since Rhinos was originally made to design boats, they kind of deal a lot with surfaces. But a lot of times when we're doing architecture, like especially massing, you don't want just surfaces, you want solid. So when I'm extruding this, it says solid. I want to click yes. I want a solid out of this. Okay. So it's not just surfaces attached. And here's my extrusion. It looks a little weird wireframe, so I'm going to go to my perspective view and click that little arrow and make that shaded so it looks like an actual square. And then, I could do the same thing. I could right click and open up, and well, I type in extrude curve. And so I could extrude this curve up and so forth. I extrude this, go up. Oh, actually, another way of extrusion is to use your gumball. You could type in gumball to make sure it's on, and it's on. So when you type in a shape, you see that little blue dot. So I can just pull that up and then extrude that. Problem is, it's a surface. It's actually not closed. So what I could do is highlight my surface and type in cap. I'll actually cap the surface so it's actually closed solid. Okay. But and that's great for masking. That's something you could do for masking. Um, this I can't. I had actually can extrude as a surface. So yeah, there you go. This is kind of cool though too. I can actually extrude this way to get a form. Okay. So yeah, let's do it. Maybe not as much. There we go. Cool. So that's my form. Okay, so let's extrude these walls. Okay, I'm going to select all this. I'm going to make sure everything is joined. And then I'm going to actually extrude curves. And I'm going to say 8 feet. Cool. There you go. So I have my walls. Okay. So yeah, so that's a good, introduction to 3D modeling. But this is it's great when you're going to create little boxes and stuff, and and nothing wrong with that. But there's also a lot of really cool stuff you could do involving shapes. And so let me get into that now. That's not based on 2D extrusion. So there's actually an idea of actually designing intrinsically three-dimensional. Okay, so I'm going to put in my different layer. I'm going to do 3D uh, uh, um, shapes. Okay, 3D shapes. And then I'm going to make sure I'm on this layer, and then I'm going to create some shapes from the very beginning. So there's some basic geometry that I could use. So here there's the normal box. There's my box. There's let's see. Oops, no, I'm sorry. There's my cylinder I could, use. This is my cylinder. Um, and then oops, I keep on going here. And then I could do a lot. There's like a cone, you know, that's there's let's see, there's spheres. Hmm, oops. And then what's really fun is a torus. Or it's like a donut. Oop, there you go. Cool. Okay. So, a different shape. I could also manipulate these shapes. Using my gumball, I could, shrink that down. Uh, uh, you know, so it get extended. So I could play around with these shapes. Um, and then there's a thing. You could also what we call is do a lot of Boolean properties, which is a lot of fun. And you could play around with that. There's sometimes hard to, kind of it's a little hard to get used to, but yeah, I could do a lot of cool stuff with Boolean properties. So so let's start off with a couple Boolean properties that we could use. A lot of uh things I do is Boolean difference. I'm basically carving out something. Okay. So to do Boolean difference, let's say I want to carve the big donut out with this form. So I just kind of pull that in here and carve this out. So it's like subtractive architecture. Um, so I could type in Boolean difference. So it says select surface or polysurface to subtract from. Yes, so I press that and enter. And then select surface or polysurface to subtract with and enter. And there you go. You kind of carved out something. Okay. Um, and another fun one is Boolean intersection. So let me make this a little bigger. Um, let's see. Okay, so it's what it does what it sounds like. It finds the intersection of both these two shapes. So type in Boolean intersection. So I'm gonna set like one, press enter. Uh, yeah, and then I'm gonna press enter for the second one, and there's my intersection section. Okay, so that's yeah. So I have this funky shape now. Okay, so there's a lot of cool properties you could do. Um, Here's the thing. A lot of times the it's it's really there's things that are easy to make with Boolean properties, but sometimes the question is, should you make them? Um, a lot of students are like, oh, that's just, I made something really cool. But then I'm like, well, this is architecture, and the question is, how do you construct it? And that is a very tricky thing. We look at a lot of Frank Gehry projects, and they look really wild and crazy, but there's actually a lot of logic systems that are there. He makes sure that everything's what we call developable, meaning that they could be enrolled. Um, and we actually a lot of times we have to make sure that something that's like uh that's we have to make sure our projects are developable as well, so we don't like create these these shapes that cannot be constructed. Things are changing now, so a lot now we have 3D printers and stuff, but just because you print that doesn't mean that it could be easily constructed. What's a good example is the Disney Concert Hall. The Disney Concert Hall, um, everything is made of metal and they're all from metal sheets, and that means they could be developable. That means they could be enrolled from sheets that can be cut. Something's changing, which is the new thing that they're building right across the street from USC is the Lucasfilm's Narrative Arts, amazing building. But that's perhaps not a developable surface, and so it makes it more expensive to make. I guess it now is constructible, but then it's really tricky to make. They actually have to make the forms twice. They have to uh, CNC it, and then they pour the concrete, and it's very tricky. So yeah, it's always kind of good to really understand what you made and ask the question, is this developable? So I'm guessing this is not developable. I could sort of tell from how I made it. For starters, when you use a torus, instantly not developable. There are certain shapes that are developable, like square, a cylinder, also a cone is developable because that could be made from flat surfaces. But a torus is not developable, and so that actually so anything you make that is made from a torus is usually not developable. To make sure to test this out, what you could do is highlight this, you go to analyze, you go to surface and on curvature analysis, and then click on auto range. Yeah, see, so like it's mostly green, which is okay. There's some blue, which is not that great. What you want to avoid is the orange slash red color. So yeah, so it's getting there. So this part is not developable. And that's not good. And so if you send this to a general contractor, they're going to be very upset because they're like, we can't make that. So even though you can make it on Rhino, doesn't mean you should make it on Rhino. You have to make sure you really understand what you're doing. So yeah, so that's not a good thing. This is not something that we can make. Uh, uh, so, but if you're able to justify it, saying that it's a very expensive museum and you're fine with the crazy costs, then yeah, then it would, you might get away with it, and you say, so just be ready to defend your design, but you can still make really cool excuse me things that's actually developable. So let's try that. So I got my cylinder and I said that uh uh a cone is developable. So let's do that. And then Maybe I can create another cone that's developable. Um, Cool. Okay, so I can, let me, play around with it. Maybe I could rotate this. So maybe I rotate it 45 degrees. There you go. Mm, and maybe move this a little bit. And then maybe I'll do an intersection between this and this. So a good challenge that a professor made for us is he made sure he asked us to not even think about architecture, just to create a shape that was developable but had no flat surfaces. So that was a good challenge for us. And then we actually had to make it with the paper models and stuff. And the paper models show that it is developable. And that's what Frank Gehry offices does. They make everything out of paper to show that it can be made from rolls of metal. Okay, so I'm going to do maybe let's do Boolean intersection. Okay, so see, oh, there you go. I already have something interesting. Um, I have a flat surface there, so that's not good. So maybe I need to rotate this. Um, maybe 45. There you go. And then there a bit more. And then maybe I'll do a Boolean difference. So subtract things. So Boolean difference. This with this. There you go. Okay, so it's carved. Yeah, there we go. So, yeah. You know what? I don't like that one. Let me make it. I don't like when it's so symmetric. So let me shift that a little bit. You got to play around with things. So mm, mm, yeah, so Boolean difference. This. Oh, there. That's really interesting. Okay. Um, cool. And then that's still a flat surface here. So maybe let's do something with it instead. Let's do another let's do another cone. Okay, and then we could use this, subtract that, and maybe I could oh yeah, there we go. So Boolean difference this with this. There we go. Okay, there we go. Cool. Not the most interesting, but still something. Yeah, I could play around. But okay, so this is should be developable because now it was made from basic geometry. Even though it looks complex, it was made from basic geometry that is developable. So when you do Boolean properties, this thing is also developable. And so we could test it out. Analyze, go to surface, curvature analysis, auto range. And yeah, I don't see any orange. So that's fantastic. That means this should be developable. To test this out here, oops. Uh, Let's go. Whoops. Where's my perspective view? Sorry. To test this out, let me make a copy. And so I told you one of the things that we had to do was to actually model our shape with paper. Um, and it was a kind of a good practice because then we could really show that it can be made. So what what we would do is your form, you explode it, click on explode, and that will make it into surfaces. Okay. And all you have to do is so I would join. See, I'm gonna unroll and unroll when I unroll it, it kind of lays out as a flat 2D drawing that I could then laser cut and so or cut by hand. When we actually had the class, they made us cut by hand because they didn't want us to be laser cut reliant. So we just had to plot it out and then tape it onto a museum board, and we had to cut it out by hand and glue it ourselves. And so that was kind of a good experience in making sure we learned about craft and making sure our models look nice. So right now I'm going to join these two. I think that should work. And then I'm going to click on unroll surface. Uh, and I'm going to click on no. I'm try that out. And then when I go to top view, let's see, did it work? Let's see. So I'm going to try that again. Yeah, it doesn't like that. So I might have to, where's my grid? Oh, did it work? Oh, it did work. No. Let's see. Did it work? No, yeah. So you guys, there's a lot of trial and error. Um, it it didn't work. You see that overlap here. So when it rolls, it'll actually like spit it out at my zeros at my origin. And so here's my 2D drawing. But you see how there's an overlap here? So I can't. Yeah, that's not gonna work. Um, so I'm gonna have to. I can't join them. Let me move this out of the way. Let's try that again. Mhm. Okay. Let's see. So I'll remove this. Here, let me. This is why it's good to make copies. Ex- uh, when I do everything. Okay. Surface. Explode. Wait. Delete this. Delete this. Let me copy this. Control V. Okay, there we go. Okay, let's try that again. Explode. So if five surfaces, I'm not gonna join anything. So yeah. I so I'm gonna go through each one and unroll them. So this one, I'm gonna click on type in unroll surface and and then yes. And there you go. That's my surface. So here's one, and then I could delete this, unroll surface, and then go to my top. That's two. And then surface. Okay, so I did that one. Unroll surface. This one, unroll. Three. Here's my surface. And then four. I think this is it. Four. Unroll surface. And then unroll surface. Roll surface. Cool. So these are my 5 pieces. So I would, scale them. So um, here we could scale these. Scale and scale. I'll do here, and then maybe bring them really small, and then yeah, and then I would print these out on a piece of paper, and and if I actually glue them together, it will actually make the model. And so you can that's how you make a model out of paper. Um, cool. To make it actually uh, you know really accurate 2D drawing, I would select these and then type in make 2D, and then I will make it 2D um 2D drawing, and that's what I would actually print out, and then I'll glue it together and make my model. So yeah, so that's one of the ways that you can make models out of paper using Rhino and stuff. So everything has to be 3D printed. Okay. Yeah. So that's one of the things that we you could do to model. Okay. Another thing is so this form is developable. So we were able to enroll everything and basically cut them out of paper and then glue them together, and you would get your model. Uh, there are this one you cannot do that. Since you saw that there was orange here, you will not be able to enroll that. But you could produce this if you really wanted to produce this model. You could create um, uh, 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 an STL file. This is huge. Remember, this is in feet, so we need to scale this. So I'm going to make a copy, Control C, Control V, and then here's my copy. And then I'm going to scale this just like before. But this time, I'm going to select a base point, but this time, and I know Ruben's gone over how to do scaling on CAD. Same idea. Um, so let's say if I want to do 1/8 scale, then I take 8 times 12. So it is multiplied by 12. So that's 96. And then find the reciprocal. So it's 1 divided by 96. So if I did so I can type in 1 divided by 96, and that's my model in a scale. Okay. Um, uh, let's do it again. Let's do another example. Let's say if I want to do quarter scale. So it'll be scale, and then remember my base point, which is where it will scale it from, and then my scale factor. So if it's quarter scale, then it's 4 times 12. 4 times 12 is 48. So then 1 divided by 48. And now it's in quarter scale. Okay. And then if I want to model this, then I go to File and then Export Selected, and um, then save it as the STL file. Okay, and then that's funny. Um, we started teaching 3D printing to some of the Nova students, but yeah, so you could save it as an STL file there. Okay. Um, and then if you save this, let me actually do this. So the model test, and then click OK, OK. And then if I actually, I'm not sure if it's gonna, you guys could see this. I'm gonna try this out. Uh, I go, if you have a 3D printer, you need a slicer. I know El Camino has amazing 3D printers. Your 3D printers are better than our 3D printers. We actually have the 3D printers. Um, are because the ones at school, they're okay. They're not as amazing as the 3D printers and El Camino you guys have maker bots. Those are thousands of dollars and they're very reliable. Um, ours is not as reliable. A lot of time, a lot of us have 3D printers at home. They're not expensive. You know, now they're like you could get like a 3D printer like from Amazon for $150. Okay, so this is my. I'm not sure you guys could see this. This is my slicer. I have a Multimaker Cura, and then I'm just going to drag in that STL file here, and then it's tiny. Let me scale it. Let's do 20 meters. All right, cool. So this is my little 3D printer, 3D print. And then a lot of times I don't need any support systems for this one. Sometimes if you're again, gravity is important. And so if you have something that's overhang, you have to have support systems. And this one, you could just turn on support systems and click on slice and it will slice the print. And oh wow, that's really fast. So it will print this thing for me in 12 minutes. Okay, so yeah, so that's an option. Okay, if you want to create some models. Yeah, with a 3D printer. And then yeah, so it's just have to export it as an STL file, and then you download a slicer. I usually use Ultimaker Cura. That's free, and you can slice it, and you send that to the printer, and apparently that'll print. It was a tiny one. That would take 12 minutes to make. Okay. Um, cool. Let's do some more stuff. Um, so we we design with booleans. We could also design with surfaces as well. So it says there's an option surface from 3 or 4 corner points. So uh you know let me let's do another layer. I'll call it surface designs. Okay. Okay. So that's great. Some designs with surfaces. Okay, so if I go um, here, I could actually create some designs with using surfaces. So I'll create a surface, and then I can attach another surface to it. You know, and then anyway, so oh, that's crazy. I don't like that one. Yeah, these kind of get out of hand a little bit, so you got to be really careful. I think with this a little bit. Uh, maybe I'll do a surface like this on the edge, on here, on this edge. Go back to it. There's my other surface. Okay, and so yeah, um, and then maybe let me join these, and I could cap them. I think no, can't cap it. Oh, it's pretty close. Okay, quit. Isn't it closed? Yeah. Oh, no, it's not. Okay, so maybe I have to close that surface with this thing. Yeah, so there we go. And then join. Cool, awesome. Um, and then yeah, so that's one another thing you can mess around with is surfaces. Okay. Um, let's see, what else do we have? Uh, oh, renders. Okay, so so right now I'm in shaded view. You could also do a rendered view, and so it'll actually like show things, like in with shadows and everything. So yeah, and you could also apply different material with it. So let's say my this one, this that's not developable the surface. Um, uh, um, let's say I could choose my material. Let's say I want to make it into wood, physically based. Do I have any wood? No, I have metallic. Hmm. You know what? Let me do it out of glass, and then maybe with uh, maybe pink glass. And so, yeah, so that's oh, that doesn't look good. That's you can barely see that. That's not do glass. Let's do metal. Yeah, there we go. And then maybe you want it highly polished as well. Yeah. And then yeah. Uh so you mess around with different materials as well, in your perspective view. Um what's also really cool is you could actually, if you want to display something, you could type in turntable, and it will actually like you could rotate, your that's better, yeah. And then and then just simply we could use this as a screen to GIF, motion capture of your screen, and then you can record uh your shape, your project rotating. Okay, cool. What else? There's oh um let's see. Um, ex- so there's also let's see one more, and then we'll go into Grasshopper. Um, it's oh God, what was that command? I don't remember. Um, to let's see the plan. Okay, put it's to um, it was come back to me. What was I haven't used that in a while. I did use it my first semester. It was really important because I had a crazy roof structure, and I had to use that. What was it called? Um, for displays, transform curve tool, surface tool. What was that? Flow, taper, no, twist. Select orient now. What was that? Let's see, plain subject display curve tools. Roll surface. Solid tools. Extrude. Yeah, well, oh yeah, there's revolve. That was important. Um, sweep. That was it. Oh my God. Okay, sweep. Sweep is also a great tool. Though, uh, yeah, well, I remember using Sweep for this complex roof system I did for my first semester. Yeah, so, yeah, I'll show you Sweep as well. Okay, so let's do let me do it on this layer. Sweep examples. Sweep design. Okay, let me go back to shaded view. Cool. Um, so let's say I have a curve. Let me make a curve. Hmm, Being weird. See. Let's go to top view. Cool. Okay. There we go. Here's that's let's do a simple curve. Cool. Okay. A good handy thing is if you press ZS, go to exactly um to the object you selected. Okay. Let's say I want to create a shape, maybe a triangle. Okay. Mm, that might, let's try it again. This, there you go. That's better. Okay. So if sweep is taking one shape and actually sweeping it through a curve. Okay. So sweep one. So select rail. So this is my rail and select sweep shape. And then I select this. I press enter and then same and it'll sweep it. Yeah, it gets a little messy sometimes. But let me try it again. Let me do it. The sweep one, select rail, sweep shape, press enter. Uh, Maybe I'll do it this way. Let's try that. Oh, that's I think maybe better. Oh yeah, that's better. So yeah, yeah. So you kind of there's a lot of experimentation. You gotta try different things. Okay. Yeah, so a sweep is a different thing. So you basically take one shape and sweep that through a curve. Okay. A lot of trial and error, you know. Mm, Cool. So okay, let's do some grasshopper stuff. So Grasshopper is amazing. It's really powerful tool. It's like having playing architects designing for you at the same time. Um, there's a lot of things you could do that you could control a lot of things that you normally couldn't do with just Rhino. It does get a little frustrating at times, there's times where things won't work. And you just have to be patient. Just try it out. There's a lot of YouTube videos. I suggest just going on YouTube. There's so many resources on Grasshopper. You just type in Grasshopper Rhino, and there's definitely a lot of good introductory videos, and you could ask questions about how to do this. It's almost like programming. It's actually using this language called Python to program, but in a visual sense. And I won't go um uh into it too much. I don't want to scare people, but you could do a lot of cool things with it. Okay. That's okay. Let's start some grasshopper. Okay. So I'm gonna type in grasshopper. And it's a plugin, so it's already built into Rhino. If you have Rhino, you already have Graphical, which is great. Okay. And close that. Okay. So this is my grasshopper. So it's really you have two screens. Um, uh, Hopefully you guys could see. Okay, cool. I can see the screen as well. It's really good if you're using Grasshopper to have multiple screens. We actually have a different screen to see, so you can see what's going on the Rhino end, as well as seeing what's going on in the Grasshopper end. Okay. So I'm gonna start with new document. This is my new document. Um, so Grasshopper, it's like programming. It's it gets a little so so for those who have done programming, it's it's very similar. You probably pick it up very easily. But with any programming, it requires a lot of patience sometimes. Um, so I'm going to start off with basic geometry. So I could type in a lot of things, just like Rhino and CAD. You could type it up, or you could go into the little things and you could pull up what we call functions. So I'm going to just start off with my basic thing called like geometry. Okay. Um, and this is my geometry. Okay. This is what I start off with. And so I am going to have to link that to something that maybe I could link with Rhino. So let's say my geometry is a circle. So I'm create as you know what? I'm going to do it in a different layer. I'm going to do it on okay, I'll make this in different color, pink layer. And then just I think grasshopper. Okay. So let's say I'm just going to start off with a little circle. Okay. And this is, and then I'm going to highlight this and right click saying set one geometry. Okay. Do you see how it went from orange to gray? That means it's this geometry, it's recognizing that this is the circle in Rhino. Okay, so I set that as my geometry. Okay, so I could do different things. I could, let's say, extrude. Maybe I want to extrude, and there's so many options. Let's just do uh uh. mm, Here we go. Just a simple extrude. Okay, and then do you see what I did? I just connected this wire. So I just pulled this wire to this thing. So it's taking my geometry and extrude. Nothing's happening yet because it doesn't know what direction I'm extruding at. Okay. Um, and so let's oops. So I have to give it a direction. Okay. There's different ways. I usually like to do a vector. Um, so this is the X, Y, and Z. Okay, in any direction. And so I'm gonna connect that vector to my direction. Okay. It's not happy because it's giving me nothing. Okay. Uh, so what's really important is to what we call number scale. So I'm going to so you could to do that a number slider. So I'm going to here's a number slider. Okay. When I just pulled a number slider, you could also type in number slider. Another trick is to just type in the number. So I'm just going to type in 10 and it'll give me a number slider from 1 to 10. Okay. And then I'm going to copy and paste. And so this is my Z, this is my Y, and this is my X. Okay. Do you see what it's doing? So here, let me make this into like my option, my maximum is 100. Wait, oh, I mean, let me type in. Okay, if I double click, it'll give you my minute and my minutes. And so I'm gonna make it to like 100. Okay, and maybe this one I'll do 100 as well. And then so you could really see the change. Okay. Um, okay. And then so now I could really just, change, I can really move it however I want. This is the y-axis, so I can move it this way, and then this is the z-axis, I can move it to that way as well. Okay. Yeah. Uh, and then let's say and and what's really cool is you could this is why you could this is like having multiple uh architects. You could okay, let's say I copy this on geometry over here and over here and over here. Now what I'm gonna set let me do an array so it's even more dramatic. um, uh, array and bring in X direction. Let's do 20. Uh, uh, these are all my circles, okay? And then let's say and oh dang it. So annoying. Okay, let me try that again. Array. Select this curve. And then so I got enter. Let's do 10. 10. Did it work? Dang it. Sorry. Array. Did not work. Let's try it again. Sorry. 10, 10, 0. Yeah, very good. Cool. Okay, this is my array. And press enter to accept. There we go. Accept. Okay, so this is my array. Make sure I highlight everything. So select my object, all my pink. And then I'm going to set this as multiple geometries. Okay. And then now when I control my slider, it controls everything. So I'm able to control like 100 of these. Okay. So I don't have to do each one. I'm actually now just like it's like a whole army of and which is cool. And then you could do a lot of cool things. If you want to do facades or whatever, but you basically are able to control multiple um objects at once. Okay. Okay. So uh, that's that's let's just focus on one though. Okay. In the meantime. So let's say okay, I just extruded it. And then I could do other cool things with it too. It's world's my oyster. So I'm just gonna wait me set set this as set one geometry. Okay. Uh, so I could also do a twist. Okay. So maybe my extrusion, I'm gonna twist it. Twist. So twist. And then so I'm gonna take my geometry and then uh and um I could twist my geometry. And you'd probably have seen like these awesome towers that are now twisted. So they actually use Grasshopper to do that. So okay, what does it need? It will need an axis. Okay, so let me do maybe my y-axis. Yeah, Y. Do let's do angle real fast. Um, so they actually okay um radians degrees. So type 90. Okay, and then I believe this triangle. Let's see. Okay, axis angle, and then um, okay, I believe I need to make this into degrees. So radians, degrees. Okay, so this may be okay. So uh, wait, actually, I'm going to do radians. And pull this here. There we go. Let's see. Okay, and then I need an axis. Okay, so let me write an axis. I think what it needs is a line. In fact, can I actually feed this vector in there? Nope, doesn't like that. Which was it run up? So let's try it. Uh, unit x, vector x, y axis. Mm, you know what? I think I need to do a line then. Okay, so I can make sure I create a line, center. Oh, let's see, around that. Okay, yeah, there's a lot of trial and error with grasshopper. Okay, so let's do. Hmm, you know what? Let me do. Okay, so I've tried different things. Let me do my notepad. I'm gonna do 0, 0, 0, 0, 10. Okay, and that might be my access. Let's try that out. No, that didn't work. Mhm. Let's see. Let's do a line. Let's, okay, let's try this one. Oops. Start point. So, yeah, 0, 0, 0, 2. It's not. Uh, start point, and then let's do 0, 0, 10. Endpoint. There you go. Oh, perfect. Okay. Oh, wow. Okay. Yeah. So a lot of trial and error. Um, actually, I don't like that it's 0, 0, 0. I might want to move that to my center point of the line. So geometry could be center, centroid from medians. Let's move this here. Move to 0, 0, 0. There we go. Perfect. Okay. Sorry. And then try that again. So I can feed in two points. One is two coordinates to make a line. So it's going to be 0, 0, 0. Um, and that's the start point. And then this is the endpoint, which is 10. And then endpoint, there you go. And so it's really funky because it's twisting in on an angle. Let's see. There we go. See, oh yeah, so it's going around that way. Okay, let's try a different one. Let's try what if I actually mess around and make it 0 and then twist it around the Y. So here, try the, oh, that's kind of cool. So it's twisting it this way. Okay. Yeah. And then you could also do it 10, 0, 0. Let's see what happens there. So it's going to twist. Oh, there we go. Oh, that's not as exciting. But anyways, yeah. So you kind of see how it works. It's basically uh putting one shape and feeding it through different functions, it gets pretty tedious at times. Sometimes it might be a little frustrating, but just keep at it. There's a lot of resources out there, and if you're also welcome to ask any questions. Let's do one more thing. Let's see. Let's do uh something that's that might be really helpful. Let's do um okay, let's just do a line. Okay, and then I'm gonna just do another uh oh, actually, let me go over one last thing before I move on. Okay, so whatever we do you see how it's in red? That means it's kind of like a ghost. It's not finalized in Rhino. You're still able to mess around with it. But let's say when you're done and you were actually done with what you created, um, you're ready to make sure you're ready to mess around with it on Rhino or 3D print it or model it. That's okay. Let me make it kind of wacky. So I remember you did 0, 10, 0. Let's see, 0, 10, 0. Okay. Okay, so it's this form. Okay, it was kind of crazy from twisting it. Let's see if I can twist it. All right, there we go. Okay. Let's say, okay, so this is my geometry. When I highlight it, it's in green. Um, but it's sort of like a ghost. It's not really built yet. So what I'm going to do is kind of right click and click on bake. And then it's gonna pull up all my layers from Rhino. I'm gonna click on Grasshopper, and then it's gonna bake it. Okay. And so now my actual design is actually baked in Rhino. And this is what I made for my Grasshopper design. Okay. Yeah. So and then yeah, and then so I could now, if I wanted to 3D print it or mess around with it further, I could still mess around with it further in Rhino. Okay. It's actually kind of cool. Oh, huh, that's cool. Yeah. So and yeah, so it's kind of um yeah, it's so you're able to create something on Grasshopper and then finalize it in Rhino. Okay. Okay, one last thing. One simple thing. So that we have this line here. Uh, you know, let's say geometry, and then I want to feed that geometry. Uh, set one geometry. So now it's this one. And then let's say I want to divide, divide curve. Okay. And then so I got to feed that curve there, and then it's divided that many times. Um, oh, let's say well here's that's divided even further. Let's do 50. I'm gonna divide it 50 times. There we go. Okay. And now let's say with each point, I'm gonna make a circle. Does it work? Hmm. You fill to from point to circle. Got it. Okay, let's do. So each of these points are here. Let's see. Circle. Uh, fit to collection. They divide the 3 points, tangent, center, normal, and radius. There we go. Okay. So now I'm going to feed that here. Oh, there we go. Cool. Awesome. And then my radius, it could be another number slider, so maybe I'll do 10. Um, there's my radius of circles. Okay. And then what if I want to extrude? I'm gonna grab my previous extrusion. Um, and then I just copy that. There you go. Perfect. And then my base. Okay, so my circles are my base. There you go. Perfect. So now, so now I have so many extrusions again. Yeah. Um, and then I could actually mess around with each of the extruded circles. Cool. So yeah, I mean, it's so much faster than me creating a circle, and circle, and then trying to extrude each of them or copying. So, and this kind of goes by much faster. Okay, so it kind of you guys are kind of getting the logic of Grasshopper. Okay, and then maybe let's bake it. Uh, oops, let's bake all my circles. Bake. Geometry. There you go. Awesome. So I can now move my circles out of the way. Could also, make them larger as well, or do other things with it. Okay. Yeah. Um, so yeah. Yeah, so that's something to mess around with as well. And then last but not least, there's this really important thing, especially with dealing with topography, is contours. And that's how you are able to model topography. Let me go back to um, and you could use Grasshopper as well. Let me close out Grasshopper. Let me just do it in Rhino for me. Okay. Let's say I have this surface. So a good way of creating surfaces, like a good way of creating topography. I'm just going to do it in 2D here. Um, let's see. Okay. And then maybe, okay. Yes. Yeah. So this is my flat, but then I could start messing around with things. Um, and then do the same thing with that. And then maybe let me fit this. Okay. And then let me move that here. See if that works. Okay, so I have these two circles. Okay. Yeah, maybe make this a little Okay. Um, okay. That's so a really important, like a good useful tool is patch. So patch. Select curves to fit the surface through. And oh, there we go. Yay, awesome. It worked. Um, so yeah, that kind of creates kind of a surface given the curves I have. Okay. And then you know and you know if I wanted to, I could you could extrude that down, so, as much, you know, or okay. So another thing I could do is with creating topography is contour. So I type in contour. Uh, so range, cool. And then, oops, try that again. Surface contour. Okay. Base point. So maybe I'll make sure this is the base point, and then I'll make sure it's in the direction I want. So I'll make sure it's in the direction I want. And then I'm gonna do maybe inches. So 5 inches. Oh, that's too much. Let's try that again. Um, contour, press enter, base point, maybe go down, and then just okay, not 5 inches, let's do 1 foot. There we go. Okay, that's a that's a okay contour. Yeah, so you had now your contour lines, okay? And then this is the lines that you can basically eventually um laser cut as well. Okay. And then that will form your topography. Okay. That yeah. So that's something you can mess around with too as well. So forming contour lines. Okay. Okay. Well, yeah, I think that covers a lot of Rhino and Grasshopper. Again, mess around with it. Um, it requires a lot of patience. You know, don't, if it doesn't work, usually things don't work out the first time. You just gotta try it again. It's a lot of problem solving. So, and there's a lot of resources as well. YouTube is fantastic. So you could ask a lot of questions on how to do certain things, and they'll have videos explaining what to do. Yeah, Grasshopper as well. Grasshopper can be very frustrating at times. There are moments where I want to throw my laptop out the window, but just be patient, try different things, try different functions. There's a lot of resources out there as well. So yeah, I hope that was helpful. Yeah, and I'd say, play around with it. And I say start modeling as well. Rhino's a really great tool to model. Okay. Yeah, and Ruben has my contact, so if you guys have any questions, you guys are welcome to reach out and stuff. Yeah, but I know that El Camino, you guys have Rhino now on the laptop, on the computer, so I suggest just trying it out. It's a good tool to have, and a lot of most schools are using it now. So most of the schools are using Rhino, and then also Revit as well. So it's kind of good to kind of understand both and take Henry's Revit class if you can. It's fantastic. Um, so yeah, it's another important tool to have. Okay. Yeah. I hope you guys found it helpful, and I'll talk to you guys later. Thanks.